There are two problems with traditional menus. The first problem is that steering through sharp corners is difficult. To combat this problem, current menus have a time delay. Time delays are also problematic because they slow down the user. There are some existing improvements to traditional menus, but they are not without their limitations. One such technique is called enlarged activation area menus. They increase the activation area. This gives the user a larger area to navigate through. One problem is that the activation area is not uniform, and in the worst case, it isn't enlarged at all. A second technique is gesture menus. This technique will either open or close the submenus based on the direction of the movement. The advantage of this technique is it decreases the distance the user has to move. There are two problems with this technique. The first problem is the user must move the mouse in order to open the submenus. The other problem is the submenus hide the menus behind it. Third and final technique is force fields. Force fields warp the mouse cursor to the center of the menu. Additionally, for parent items, force fields exaggerates the displacement of the cursor to the right-hand side. The problem with this technique is when the user enters an undesirable submenu, the user has to fight against the forces imposed by the warping technique. We designed a new technique called Adaptive Activation Area Menus. This technique alleviates the steering problem, and it also eliminates time delays for posting and unposting submenus. This menu has a semi-transparent triangle, which acts as an enlarged activation area. We also added force fields to our technique to create Force AAMU. Participants performed significantly better with adaptive activation area menus than default menus, and they performed equally as well with force menus and EMUs.